All right, learning target 1 for Unit 4. Our first learning target of this unit is to justify whether a relationship is a function from a description, table, or graph. Okay, so hopefully you guys have heard that word function before. We're going to define what a function is here. A function assigns to each element of the domain exactly one element of the range. Okay, and that's kind of just a fancy way to say that each x has exactly one y. If you see here, the domain is all the x values, or the inputs, like you might have called them before. The range is all the y values, or the outputs. Okay, so if we have a group of y's, or x's and y's here, each x can only go to one y. Okay, so x, if we have x1, y1, x2, y2, x could not go to both y and y1. That would not be a function, okay? And we're going to take a look at that in both a description and a table and a graph, okay? So a function, each element of the domain, each x, or each input, has exactly one y, okay? One element in the range. Okay, and we're going to look at some examples here. So we are asked to tell whether each table of values represents a function. If not, explain why not, and then give the domain and range of each relation. Okay, so our first table here, we have inputs and outputs, or x's and y's. Okay, and we have 1 going to 2, 2 goes to 4, and 3 goes to 6. Okay, sometimes to check myself in a table, I like to write out all of my different inputs and all my different outputs, and then just draw a line to each of them. 1 went to 2, 2 went to 4, 3 went to 6. Okay, so if I don't have one x, or one input, going to multiple outputs, then yes, this is a function. Okay, each input goes to only one output. I have only one arrow leaving from each input. Okay, so if we're asked the domain and range, the domain would be 1, 2, and 3. Okay, the range would be 2, 4, and 6. Okay, and notice this is not 1 through 3. I did not write 1 through 3 because we don't, 1.5 is not in our domain, 1.7, 2.8, all of those decimals in between 1 and 3 are not in our domain here. So our domain is a set of numbers 1, 2, and 3. Same with our range is 2, 4, and 6. Okay, so let's move on to table B. Again, I'm just going to write our x's and our y's. We have in the inputs 1, 0, and then we have 1 again. So I'm just going to write 1 once. Okay, and then in the y's we have 1, 2, and 5. And if I go through here, 1 goes to 1, 0 goes to 2, and 1 goes to 5. All right, and here I notice that I have a problem. I have 2 arrows leaving from the input of 1. It goes to both the output of 1 and the output of 5. And that means we do not have a function, okay, because 1, the input 1, has 2 different outputs. Okay, if we were to look at that on a graph, at 1 we would have a dot here at 1, and we would have another dot up here at 5. And that is not considered a function, and we'll talk about graphs here in a second. And we'll move on to our last table here. We have x's and y's, 1, 2, 3, 4, 5, 6, and 0, 0, oops, 0, 0, 0, 0, 0. No point in writing that 6 times. So 1 goes to 0, 2 goes to 0, 3 goes to 0, 4 goes to 0, 5 goes to 0, and 6, surprise, surprise, goes to 0. Is this a function? Definition of a function. One input cannot go to more than one output. Okay? A function can have different or multiple inputs go to the same output. Okay? This would just be a bunch of dots here at 0, right? And this is going to be a function. So our domain is going to be the set of numbers 1, 2, 3, 4, 5, and 6. And our range is going to be just the set of numbers 0. All right? So let's take a look at this on graphs, because there's a nice little trick we can use on graphs. You have a bunch of graphs in your video notes here. I want you to get down that we have such a thing called the vertical line test. If a graph does not represent a function, you can draw a line, a vertical line through it, and it will cross that line. Your graph will cross that line more than once. So let's make a line here. If I just make a vertical line, we can use this line to test our functions. If I pass through a graph and I only touch one point of the graph at a time, as you see, as I move this blue vertical line, I only have one point of my graph touching it at a time. Okay? Then I have just passed through a function. At no point did I have 2 points of my graph touching this vertical line. Okay? If I pass through this graph, I'm fine, I'm fine, I'm fine. And then when we get to here, I now have 2 points of this graph touching my vertical line, which means at whatever x value this is, let's say this is the x value 5, I have 2 different outputs that go with 5, and that is not okay, that is not a function. Okay, so a vertical line test is a really nice way to check on a graph. We can slide through here. This one is going to be a function. At no point do I touch 2. Here, I touch 2. I even touch 3 points on a graph here, so this one is not a function. And then finally this one, this might be the first time you've seen a graph like this. Open circles represent no data there. Okay, so this is a function where I have this point, and then it's going to stay this point all the way until I get to here, where my y value moves up here, and there is no, that open circle is representing no data in that circle. Okay, so this one actually does represent a function as well, because at no point am I crossing, at this point I'm crossing the data up here, the y value here, and then no data here. All right, so this is a function, not a function, function, not a function, and function, okay, for our graphs on your note sheets. Before class, and I want to look at one more option here, there are many real-world examples that show functions and not functions. For example, a Muslim man can have 4 wives. Okay, so if we talk about men and their wives as a function, this would not be a function, or as a relationship. This would not be a function, because one man, let's call him the Muslim named Bob, can have multiple wives. Okay, he can have up to 4 different wives. He can have Mary, he can have Sally, and he can have Betty. All good Muslim names, right? So Bob cannot have 3 lines. If we put this on a graph, that obviously does not pass the vertical line test. One input has multiple outputs. Okay, so your task for class is, can you think of more real-world examples that are functions and that are not functions? Try to bring one of each to class. Do not Google to find these examples. Be creative. Think about all the different things that can have more than one output, or all the different things that are unique person to person. All right, and then bring that to class.